arithmetic expressions and the enhanced cash register. So there's another cash register assignment. We were working on one in chapter 3, but in the one in chapter 4 is a little bit more detailed. It's not a great cash register. It's kind of contrived. So I realize for some people this cash register doesn't make a lot of sense. No pun intended, but it does exercise some things about the Java language. So I think we're looking more to try out some things in Java rather than to create a very useful cash register program here. Let's see what it has to talk about. So when you're doing cash registers or keeping track of money, you need to do a lot of arithmetic, adding, subtracting, division, modulus operators. There's all different types of arithmetic operators that you can use when you're especially when you're dealing with money. I was talking to my brother over the weekend. He's an accountant, and he's working on a huge system for a bunch of golf courses down in Phoenix. And I used to write property management software, and so he and I were kind of picking each other's brains on ideas on how he might go and approach that. Since I have a lot of experience writing accounting software, I can actually talk to my accountant brother, and we can actually speak English or speak accounting speak and understand what each other are saying. And so I'm trying to help him out as he tries to gather the requirements he needs for his system. Well, same thing here. What we're doing here is we're keeping track of money. For some reason, people get really upset if you put money in the bank and it magically disappears for some reason. You have to, when you're dealing with money, you have to make sure that you don't lose track of what their balance is, especially at the bank. That happened to me once. I went to the bank and there was $1,500 missing. I go, well, where did it go? And so we figured it out. These two ladies that had the same name, my wife and this other lady, wrote checks to each other, and the teller got confused and subtracted from the wrong account. So that was kind of embarrassing. They fixed that though, for the bank certainly. So we want to discuss various aspects of how to do mathematics using the Java language. You don't write it like you do in math class. Again, the computer's not very smart, so you have to write it a very specific way. So we're going to take a look at the presentation and see how we go about doing that. I always forget to look at the slide numbers, slide 19 through 34. So we have kind of a long lecture today. We're starting here today, arithmetic operators. Now, you've probably seen this lecture in your math classes. This is similar to what you see in math class, but there's a few notable differences I want to point out today. Again, there are 4 basic operators. When you're dealing with math, there's addition. That hasn't changed. Subtraction, that hasn't changed. Multiplication, well, yeah, there's no dot key on the keyboard or a little X maybe for multiplication. So what they do in computer land, in most computer languages, when you're multiplying things, they put in the asterisk as the multiplication operator. The other thing about this is that when you're multiplying 2 variables together, in math class, you can just stick them next to each other and the multiplication is implied. The computer doesn't know anything about that. You actually physically, explicitly have to put in this to multiply things. It doesn't do implied things very well. There's division. That's normal for division, I guess. Kind of a slash, looks like a fraction, I guess. First things first, just like in math class, parentheses control the order of sub-expression computation. So which do you do first? Do you divide b by 2, or do you do the things in parentheses first? Well, the parentheses take precedence over any other operator. So it's going to do the parentheses first before it does the division. This is really important because you get a different answer if you don't have the parentheses in there. It'll do the division before it does the addition, and then you'll get a different answer, probably not the right answer or the one you expect. Yeah, from this one, no, you're not excused from this one yet, because I expect this one is going to be done by Friday. So my goal is I'm trying to figure out when's that last day I can expect something from seniors. So I think the last day I can expect something is Friday. So whatever we can get done before Friday. I'm thinking this dice roller thing is going to be our last one. So what we just talked about today. No, I think there's others. I think Andrew here is asking a question. I think he's a senior. Yeah. Logan was asking, am I the only senior in Java 1? And no, we have, I think, lots of seniors, not tons, but some. Multiplication, division bind more strongly than addition or subtraction. So if it's not specified with parentheses, it's going to do the division and the multiplication first from left to right before it does the addition and subtraction. So again, we'll do this addition first because it's inside parentheses, and then it will do the division. Now, there's a couple of operators that you may not see in other places, especially in math class. There are some weird ones, and so we want to go over some of these strange ones. First one is the plus plus operator. Basically, it's the increment operator. What does increment mean? You just add 1 to. You do this a lot in computer land. You add 1 to things a lot. So they figured, well, let's just make it really concise. Let's just make an operator called plus plus, and it will automatically add 1 to that variable. And then we don't have to say items equals items plus 1. Programmers are notoriously lazy typists. They don't like typing the same thing over and over again. So what they do is they shorten it and give you a new operator, items plus plus. Now, there's a language called C++, and it's kind of a joke. The name itself is a joke because the first language was C, and then the object-oriented version of C, it's one better than C. So they call it C++ because that's the increment operator. It's like the next version of C, I guess. So if you've ever seen that C++, you can think of it that way. Plus plus is the increment operator. C++ is one better or one more than C. And it is kind of. So that's kind of interesting why it's called that. There's also a decrement operator, takes 1 away. So you just say minus minus. I think you have to put them right next to each other or it's not going to see them. You can't put a space in between. Sometimes you can do that in Java, but with operators, I think you have to put them right next to each other. So it just takes items and adds 1s to items and then stores it right back into items, that slot in memory. So that's how you increment a value. This is a lot more concise than that. So most people use this. But for beginning programmers, it's not as clear. So usually with beginning programmers, I say this, but for more seasoned programmers like Java 2 programmers, I would say items plus plus and assume that everybody knows what that means. Now, there's this weird thing about division you have to be careful about. First of all, integer division is pretty strange. When all you have is integers, remember integers are whole numbers. They can't have a decimal point. They have no fractional portion. So when you do division with integers, you don't get a remainder. You just get how many times that fits in, and then it just truncates off any remainder or any fractional portion. So, for example, if both arguments are integers, the result is an integer, and the remainder is discarded. So you just it basically ignores the remainder and tosses it away. It's not used to figure out the thing to the right of the decimal point because there is no decimal point with integers. We're talking whole numbers. If you take 7.0, which is a double, the reason why I know it's a double is because if you take the time to put in a period and a 0 or a decimal point and a 0, that's telling the compiler, hey, I want this number to be treated like a double, not as an integer, even though it's a whole number, it's 7. But I want you to treat it as an integer. What happens is this 4 gets promoted up to be a double, and you get this answer. However, if you have 2 integers, like we have here, and you divide one by the other, it's just going to tell you how many times it fits in, but not give you any remainder or any decimal point or decimal point after. So 7 divided by 4 is 1, not 1.75. So you have to keep that in mind when you're working with integers. You're going to get that decimal fractional part truncated off, chopped off, if you use just integer math. Now, there's a strange operator that you've probably not seen before unless you program in other languages. And this is called a mod operator or a modulo operator. Everybody just calls it mod. They use the percent sign in Java to signify a mod operator. And what a mod operator is, it's a type of division, but instead of returning you the quotient, how many times does this thing fit into that thing, it returns the remainder. So I call it the remainder operator. When you divide 7 divided by 4, well, that's one time, but you get a remainder of 3. So what you get back is 3. So you get back the remainder of the division, not the actual result of the division, like the quotient. And you use this one all the time in programming for some reason. Just there's in really neat and strange situations. You can use the modulus operator, and it makes the code a million times easier to understand. So that's a new operator you probably haven't seen before, this remainder operator, the one that returns the remainder. It's a type of integer math, but you can get the remainder from it. All right, so here's our example. This is taken from our enhanced cash register we're going to be working on in this chapter. And so we're making a bunch of constants. These are, I guess these are, I'm trying to think where this is. This is probably in the tester. So these are constants, right? You can tell they're constants because they're all capitalized. They have the keyword final in front of it. All the words are separated by underscores. And you have pennies per nickel, pennies per dime, pennies per quarter, pennies per dollar. And those aren't going to change, right? The value of a dime doesn't change. It's always 10 cents. So you can make that a constant pretty confidently. Now, if you want to compute the total in pennies, you can take the number of dollars you have and multiply it times the number of pennies per dollar, and then the number of quarters you have and multiply it times the number of pennies per quarters, and keep doing that until you run out of different types of coins. And then what you're going to get is the number of pennies you have. Now, if you want to print out dollars and cents, then you can say, well, you can take your total and divide it by the pennies per dollar, right? So you're dividing by 100, and that will give you the number of dollars. But for cents, it's kind of interesting. What you do is you take the total number of pennies you have, and you do a modulus operator. So you still do the division, but instead of caring about how many times these 100 pennies go into the total, you're concerned about the remainder, which is what you need for the decimal point and to the right of decimal point for dollars and cents. So remember, I told you about a bank that was doing all their math in floating point and getting a lot of rounding errors and struggling and how slow it was. And I say, well, why don't you do it this way with pennies? Use integer math and do tricks like this, and your processing becomes like 10 times faster. And they did that, and it made their system just scream, just because we changed the data type. So this seems kind of silly, but behind the scenes, if you compare floating point math to integer math is going to win hands down when it comes to speed, because it's a lot less complicated. There's a lot less to do. Other things that you might see mathematically is if you're doing a lot of scientific programming, say you're trying to support some kind of science experiment or some kind of analysis or simulation, especially like physics simulations, you're going to use a lot of things, a lot of fancy equations where you need powers and you also need roots. So there's this class that's provided. It's a static class, or it's basically a abstract class. You can never create a math object. The math class is just a way of grouping a bunch of math methods that work together into one place or into one class. So there's methods like square root. If you need to take the square root of something, you call the square root function or method. And then there's one that's funny. I always like the name of this one, pow. Okay, that's for raising something to the power of something else. Now, strangely, Java does not have an exponentiation operator. In C, you have the little caret that can raise things to a power. But you actually have to call a method to raise something to a power in Java. So to me, this seems like it's really lame. Because in C, you're always worried about the economy of expression. You want to say it's in as few characters as possible what you're trying to do. Well, if you have to call a method called pow and then put in the parentheses and say, okay, what are you raising to a power and what power do you want to raise it to? and make it into a method, it's a lot of extra typing to do something that should be really basic. But this is a kind of a wart on Java, is that they have no way of doing exponents without calling a method. So this is really lame for people like me, I guess. So if you want to compute a variable x raised to the n, it'd be nice if you could write it like that, but you can't. You have to say math.pow. You put the base right here, and then you put the exponent right there. So that's a little bit strange and way too much typing. However, if you're just doing x squared, you can do this a lot more simply. Just say x times x. Again, that's economy expression. You get the same answer. And so you see a lot of programmers do that. They only do that with square things. They don't do that with cubes. If they're going to do a cube of something, then they usually call pow. But if they're just doing a square, instead of going to all the trouble of saying math.power x comma 2, you would say, well, just multiply x times x. Ta-da, it's squared. To take the square root of a number, you just call math.square root. For example, you say math.square root of x, and it will tell you what the square root is. Obviously, that's probably a double coming back, because you're going to have, in most cases, a decimal point and things after the decimal point. So if you're doing the binomial theorem equation, I think that's what this is. Negative b, this looks a lot different than what you see in math class, right? Negative b plus, so we can't do plus or minus, so we say plus math.square root b squared minus 4 times a times c. And then we divide that whole thing by 2a. Is that quadratic? I thought it was binomial theorem, but yeah, you're right. That's quadratic. Yeah. So that's one of them. There's two of them, right? There's one that's negative, right? So that looks a lot different than math class, right? You're used to seeing a little square root symbol, and you're seeing like squared. You got b times b. That should be b squared, right? So the way you see an equation, or you would write an equation in Java, is much different than what you see in math class. Okay, just be aware of that, and that's what this chapter is all about: is how do you write what I want to say? How do I translate from math jargon to Java arithmetic code? And that's how you would do it. So yeah, that one. So when you're analyzing the expression, what order does Java do things? Well, we said the innermost parentheses are done first, so it's probably going to do the b squared first. Well, do this one first because it goes from left to right. So I'll do b squared, and then I'll figure out this. That's multiplication. Doesn't do the minus yet. There's another parenthesis over here, so I'll do that one next. So here you've consolidated these into b squared. That's 4ac, and that's 2a, right? And then what you do is we're still inside this thing. So that gets condensed down to, that'll probably happen before this happens over here, actually. So you'll get b squared minus 4ac finally all in one place. And then this occurs. Finally, you take the square root of that. That's this part. And then, so that square root happens first. Why would that happen first? I suppose because it's a method. It's not an operator. So it's going to call that method. And then finally it adds on the negative b. And then finally after that it divides that whole thing by 2a. So you can see the process in which the Java compiler will try to figure out an answer here. And it's really important that you get this order right, and that you understand the order when you write the equation, because you'll get the wrong answer otherwise. Okay. So here's our methods that you might use quite often. There's math.square root, math.pow. We talked about that one. If you want to take the exponent of e, you can do that. E to the x. Logarithms, natural logarithms are just dot log. It has all the different flavors of trigonometry methods. So sine, cosine, tangent, arctangent, all of those are in there. If you want to round to the closest integer, you can just call math.round. I'm not too sure about that one. I thought I saw somebody's code where they did math.round and it rounded to the closest hundredth. So I don't know. It maybe depends on what you send in. And then minimum and maximum, you can pass in two numbers and it'll tell you which one's larger or smaller. So these are common methods you might call from the math class. But remember, there is no such thing as a math object. You would never call new or call a constructor for math object because one doesn't exist. Math class is just there to group all these methods that are math related together. Okay, so let's see. What slide were we supposed to go to? We are on slide 26. So there's 34, so we keep going. Here's some other operators or methods that you might try or might run into when you're looking at Java. Cast is kind of different. It's basically, it takes one value of one type and transforms it into another type. So if you ever work with metals, I don't know if you have, but you can make a plaster cast or a cast of something where you take a negative copy of it and then pour in like lead or brass or something, and then you can make it a copy of that shape. Well, that's what kind of doing here. You're reforming data from one type into another. For example, here we say total plus tax, right? And you get balance, but then if all you care about is the dollars, what you can do is just cast it to an int, and that will chop off the decimal point. That'll force it into an int, which is a whole number. It won't round or anything. It'll just chop everything off. All the cents get chopped off, and that's what you get for dollars. So the way you cast from a double into an integer is you just put the data type int inside a parenthesis. So it's very strange looking. Now, C and C++ went away from this type of syntax because it's not very clear what's going on. They have different types of casts that are better. But Java decided to keep the old way of doing it. And so we're looking at the old junk. Math.round converts a floating point number to the nearest integer. So if you take balance and it's got 0.50 or higher, it's going to round up. Otherwise, if it's below 0.50, then it's going to round down. So 3.75 gets rounded up to 14. But if it was 3.49, it'll get rounded down to 13. That's what round does. Now here's the formal syntax card about casting. Basically, you just put the type name in parentheses, and then you say what you want to cast. So we say balance times 100, and we want to make that into an integer. We can do that, and that basically truncates off any decimal point and anything to the right of decimal point. Just chops it right off. And they call it an operator, so it's a type of operator. So we're looking at arithmetic operators. This is a type of operator as well. Is it a type of arithmetic operator? I don't know. I'm not sure if it's grouped with the same, but it is a type of operator. Whether it's arithmetic, I'm not sure about. So here's some arithmetic expressions you might run into just generally in math class. X plus y over 2. How would you write that in Java? It would look like that. Parentheses are important because you don't want that division happen to y before you add it to x. So the parentheses are required. If you say xy over 2, remember that the computer doesn't understand implied multiplication. You have to physically or explicitly state you want to multiply those two things together. So you do it like this. Notice there's no parenthesis this time. Why is that? Is because both multiplication and division are at the same level of precedence. So it does it from left to right. So it's going to do x and y first before it divides by 2. Would it matter? Well, no, the order really doesn't matter in this equation. If the order does matter, though, I usually put the parentheses in. Even though it's going to work the way I want without the parentheses, I always tend to put them in just to be really clear about what happens first. Here's one that's a little bit complicated. You have this whole equation that gets raised to a power of n. You're going to have to do the equation first. So you say 1 plus r divided by 100. It's clear that we want to divide r by 100 before we add it to 1. So that's going to happen first. Notice there's no parentheses, but it's going to do that first. Then it's going to add the 1. And then it's going to raise it to the power of n. So complex formulas are flattened. Okay, so this formula has lots of different parts to it. It's got an outside part, an inside part. It's got a division inside. Basically, it gets flattened and put on the coding line, and it looks like that. Here's one you see a lot. This is Pythagorean Theorem, I guess. And so you get a squared plus b squared, square root of that gives you a c squared. So you see that. And again, they're doing that trick where you don't have to use pow. You could just multiply with the self. That's the same as being squared. And then if you did this one, I plus j plus k over 3, you want to make sure those additions happen before you divide by 3. You want to get the whole expression or sub-expression put together before you divide by 3. Now, if I, j, and k are integers, using a denominator of 3.0 forces floating point division. But here, if these are integers and you use 3 and not 3.0, it's going to do integer math. And then you're not going to get any remainder or any decimal point. All you're going to get is how many times does 3 go into that? That's all. No remainder, no decimal point, no fractional portion. If you do want that fractional portion, then you have to convert one of them to a double, and that will force all the other ones to be a double as well. Okay. So what is the value of n after the following sequence of statements? We subtract 1 from n, we add 1 to n, we subtract 1 from n again. Remember, that's the minus minus operator. We subtract 1, we add 1, we subtract 1. So it's going to be 1 less than whatever it was before. What is the value of 1729 divided by 100? Well, let's see, how many times does 100 go into that? Well, these are both integers. Notice they don't have a decimal point or a 0 after them. So it's just going to throw away the remainder. So it's going to go in 17 times. Yeah. Here's the modulus operator. Here you're trying to find the remainder. So if you take this number and divide it by 100, what do you get as a remainder? Well, it'd be that 29. So that's what you get back. Here's another self check. Why doesn't the following statement compute the average of S1, S2, and S3? Here you have 3 numbers. You divide them by 3. You have the average. Well, you got a couple problems here. First of all, only S3 is being divided by 3 because division has a higher precedence than addition. So it's going to do this first, which is not what you want. If these are integers and that's an integer, you're going to get huge truncation errors. So your average isn't going to be very average, even if you put the parentheses in. So if you really want the average, you want to be you want to avoid integer division, then you have to put a 0.0. So the best way to write it would be like this. Just to be really clear, I want to do the additions first, and then I want to divide by a double. So I want to promote whatever that number is. If it's not already a double, promote that to a double, and then divide it by 3. And then you're going to get an accurate result. Another self-check. What is the value of math square root math.pow x, comma 2 plus math.pow y, comma 2? Well, basically, again, it looks like the Pythagorean theorem. Hopefully I'm getting that right. I don't know. I actually read a whole book on the history of mathematics. You figure I'd know these equations like the back of my hand, but it's been a while since I read the book. But x squared plus y squared, take the square root of that. And that's how you would write it. But again, probably the better way to write it would be, instead of calling math.pow, you say x times x plus y times y. It'd be more concise, more typical of what people would normally do. When does the cast long x yield a different result from a call to math.round? Well, long is basically a really big integer. It's 8 bytes long, I think, instead of 4. So you can store really huge integer values, whole numbers in there. And so if the fractional part is greater than or equal to 0.5, then you're going to get a different result, right? Because it's going to round up. And so whatever you had for x, say x was 7.6. If you cast that to a long, well, that's an integer, so an integer type. So it's going to chop off that last bit and it's just be 7. But if you have that 7.6 again and you round it, that's going to round it up to 8. So you're going to get 2 different answers. Now, how do you round the double value x to the nearest int value? Assuming that you know that it's less than 2.2 times 109. Sure what they're saying there. I don't think they mean times. I think they mean 2 raised to the 109th power. That's the limit of a integer. No, that's the limit of a double. That's as large of a double as you can do. So that'd be 2 raised to the 109th power. What you do is you round it, and then once it's rounded, then you force it to be an int. So that's how you do that. All right, so that's everything on arithmetic expressions. And we're going to use a lot of these kind of things that we just learned in our enhanced cash register class. So let's take a look at that real fast. Now, the code for this is actually in your book. It's also in the slide presentation. I think later in the slide presentation, let's look. I'm looking for a whole bunch of code. There it is, cash register. It's right there. Okay, so what we should be working on coding-wise today is to, you can look ahead if you want to start coding the cash register. It's actually in the book, and it's also in the slide presentation. So you want to review that. And this is what needs to change. First, modify your cash register class that you create in chapter 3, starting on page 88. Next, add the changes to the class specified on page 120. Remember to include the new coins, constants, and replace the enter payment method as it's shown in the book. So this is a very detailed description. It must be really complicated and very confusing. So make changes to your existing cash register project to satisfy the new requirements in programming projects 4.1 and 4.2 on page 144. For project P 4.1, create separate methods for entering the number of each bill coin individually instead of all at once. And then for project 4.2, you'll need to keep track of the number of purchases made per transaction. And so there's other things you have to do. So it gets really super complicated. Now for seniors, this is your last assignment, I would imagine, because there's lots to do here. But luckily there's a video that walks you through all this too. So anyway. What we'll do tomorrow is if there's questions, I'd like everyone to give this a try, and then if there's questions or something's not clear, then we can get those cleared up tomorrow, and then you can go strong into Friday when this is the last day for seniors, and they can get the assignment done. All right. I guess that's everything, for today for Java 1. Is there any questions from anyone on what we just talked about?